Welcome to aminacademy.com. In fluid mechanics, let us discuss about oscillation or rolling of ship. Here, look at these figures. Consider a floating body like a ship which is tilted through an angle by an overturning couple as shown in figure. Let the overturning couple is suddenly removed. The body will start oscillating. Thus, the body will be in a state of oscillation as if suspended at the metacenter M. Like through the metacenter, this ship is oscillating like. The only force acting on the body is due to restoring couple due to the weight W of the body force by buoyancy Fb. This only the controlling force is Fb here, and overturning couple with Fb and weight W. Now we'll start the problem now. Restoring couple is W into distance Ga. Here distance Ga, that is, we can say, which is equal W distance Ga in triangle, we can say it is Gm sin theta. G into m sin theta is Ga, therefore W Gm sin theta. This couple tries to decrease the angle. This couple tries to decrease the angle angular acceleration, therefore you can say angular acceleration of the body, that is of the ship, that is alpha equal minus d squared theta by dt square. Here minus sign been introduced because of the restoring couple tries to decrease the angle theta. It's a reducing manner. Then torque due to inertia. Torque due to inertia is moment of inertia. Moment of inertia about y axis, and angular acceleration into alpha. Therefore, we can write this one is Iyy into minus d squared theta by dt square. But we know that Iyy equal W by G k square, where k is radius of gyration. Radius of gyration. Now where W equal to weight of the body and k is radius of gyration. Therefore, inertia torque is given, that is equal W by G k square and minus d squared theta over dt square. which is equal minus take out like minus W by G K square d square theta over dt square. Now this is 2. WGM sin theta is 1 here. This also overturning couple, restoring couple. Therefore, restoring couple is equal to inertia torque equating 1 and 2. 1 and 2, we will get W GM WGM sin theta equal minus W by G K square d square theta by dt square, or we can say W both side cut GM sin theta equal minus K square over G d square theta over dt square. For small angle, we can say sin theta is equal to theta. Therefore we can get GM into theta equal minus K squared by G d squared theta by dt square. Now throughout divide by K squared by G, we have GM into theta by K squared by G equal minus d squared theta by dt square. Now collecting one side, d squared theta by dt square plus GM, this G will go up, GM into G over GM into G into theta over dt, GM G theta by K square equal 0. Now this is a differential equation, second order differential equation. It is second order differential equation. Therefore, the solution of this differential equation is, you can write theta equal C1 sine of square root of GM into G over K square plus C2 arbitrary constant C1 and C2 into T plus C2 cos of GM into G by K square. Where C1 and C2 are constants. Where C1, C2 are constants, arbitrary constant. Now boundary, we will substitute boundary conditions. boundary conditions are at t equals 0, theta becomes 0. At t equal t by 2 time period, that is that you can say theta equal to also 0, where t is the time period, where t is time period of oscillation. Now let it be this this is equation 3 now. Now we'll substitute this first boundary condition, the secondary. We substitute first boundary is 0. From first boundary condition we have 0, that is theta equals 0. We have C1 into 0 sin 0 0, theta is 0 because, then plus C2 into cos 0 is 1. Therefore we can get from this C2 also 0. Now substituting the second boundary condition, then 0, theta is 0, then C1 sin gm into g over k square into t by 2, where theta is t is t by 2, then here, but C1 cannot be equal to 0, cannot be equal to 0, and so other alternative, and so we can say sine of gm g over k square into t by 2 is 0, which is equal sine pi also 0, we can say. Therefore both side sine is there, so remove that one. We can say gm into g over k square square root into t by 2 equal pi, that is sin theta is removed. From this we can get t equal cross multiply 2 pi by k square over gm into g. This is a time period of oscillation. Therefore time period of oscillation of the ship equal, or floating body, is equal t 2 pi root k square over gm into g. So we got the relation. We have done. Please subscribe our YouTube channel.